Forces and Newton's laws. So, what are forces? Forces can cause changes in motion. Forces can cause accelerations. Forces can act through or at a distance. The SI unit for forces is a Newton, which is a kilogram times meter per second squared. And forces are vectors. Free body diagrams help analyze a situation. So here's an example of a free body diagram. In this diagram, the normal force going up is equal to the weight going down. There's an applied force going to the right and a friction force opposing that motion. And this is what a free body diagram would look like. Newton's first law states that an object at rest and an object in motion continues in motion with constant velocity unless the object experiences a net external force, which means an object wants to keep doing what it's already doing. Inertia is the tendency of an object to resist being moved, or if the object is moving, to resist a change in speed or direction. Examples of Newton's first law: seat belts are designed to help prevent inertia of the driver and passengers in a vehicle. So if a vehicle stops suddenly, you notice that the seat belt kind of catches you from continuous movement, otherwise, you would go through the windshield. A magician pulls a tablecloth out from under a set table without disturbing the set table. This is also an example of inertia. Net force and inertia. The sum of forces acting on an object is the net force, and mass is a measure of inertia. Equilibrium is the state in which the net force of an object is zero. That means that all of the forces cancel out. Newton's second law states the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass. So for the formula, it's the summation of the forces is equal to mass times acceleration. Newton's third law: if two objects interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and these two forces are opposite in direction. So Newton's law says that forces come in pairs that are equal in magnitude but opposite in direction. Examples of Newton's third law? Well, Newton's cradle is an example that's shown in the picture to the side, or even a ball thrown against the wall where the ball comes back, that the force of the ball hitting the wall is exerted on the wall while the wall is exerting a force back on the ball to make it bounce off the wall. Thanks for watching. Have a great day.